Hello, welcome to my Tech Fun. My name is Igor and this is the review video of Prusa MK4 3D printer. And I bought this printer myself. It arrived maybe a month ago, only I didn't have time to assemble it because this is a kit which requires 8 or 10 hours of assembling. Now it's a little bit hard to explain why I bought it, because in this price range basically you can buy much faster enclosed printers like I don't know, Bamboo Lab P1P or K1 and similar printers. Maybe just my curiosity, because my first printer was Mark III and I bought it 5 years ago with zero experience with 3D printing, and I'm very curious what are the improvements with this version. Now there is one advantage of these printers, and I think that's the reliability. A lot of print farms are based on Prusa Mark IIIs and probably now Mark IVs. They're not so fast like, I don't know, Bamboo Lab or K1 printers, but the reliability is very high. Now a few more specifications. The build volume is same like with the Mark III, 250 and 210 in X and Y direction and 220 millimeters in Z direction. This means I can use the same bed size, and for Mark III I have basically all Prusa sheets there, and also I have some extra ones too. Now, interesting on the specification, I can see the maximal temperature here is 290 degrees Celsius on the nozzle. Interesting, because the older version has the 300 degrees Celsius. On the bed is 120 degrees Celsius. On the mechanics there are some improvements. It uses now 10mm rods, not 8mm, and linear bearings on them. It has better screen. Now, very important for me is the extruder with the quick swap nozzle. And actually this is sent by Prusa. This is a nozzle adapter for the extruder with the hardened steel nozzle, because they saw my video where I was comparing brass versus hardened steel nozzle, and I was curious how much better layer adhesion we have with the brass nozzle, or how much we have to raise the temperature to get the same layer adhesion with hardened steel nozzle. And they would like to see similar video with the Mark IV and using this nozzle adapter. Now this video will not be about assembling of this printer, because it requires maybe 8 or 10 hours, I will see, because the Mark III, for that 5 years ago I needed 10 hours, but I had zero experience with 3D printing. So now I have a day off today, and I thought I have 8 hours because all my family members are in school, except my youngest daughter, because she is here, she has a flu, but I hope I can work next to her. I'll try to do some short reports after I assemble, I know, different groups like Y-axis or extruder or similar. Let's see what's in the box. This was content of the box, and immediately we start with gummy bears, but these are not for me. I will give this to her because I'm on some kind of diet. So all parts are grouped in different boxes. So here we have the motor kit, the power supply unit, extrusions and plates, and these are different sheets like the frame or hotbed sheet and similar. These are rods, printed parts and the case, and these are fasteners and electronics. One sad thing I noticed, so this is only the handbook. I mean, very useful informations are here, but for the kit I need assembly instructions. And only now I figure out that assembly instructions, I only have this QR code or the link where I can download and watch it online. Because with the Mark III, I got this. A printed version, very detailed instructions. Of course, we don't have so much waste now with this version, but this was very comfortable for the use. But I understand they are saving some money here. So these are online instructions, and I will do some report when I finish some chapter, and I'm starting with the frame assembling. Well, actually there is a big advantage of online instructions, and that's that we have these comments by other users too. An important step in this part is connecting the alloy extrusions. This chapter is finally finished, and one small thought first. This is part from PETG, which holds this white stepper motor, and I know this stepper motor may get hot. On industry I measured it can be 60 or even 70 degrees Celsius inside the enclosure, and that may be too much for the PETG. Now then I realized there is a thermal pad here between the stepper motor and this metallic frame, so this metallic frame will also act like a heatsink. And now I can move to the X-axis. I'm still working on X-axis, and one interesting thing I noticed that I'm assembling now these ball bearings, linear bearings, and there is no brand on them. And I'm quite sure that with all the Mark III's or Mark III, I got the Misumid bearings. If I find them, then I will show you some footage here. In the meantime I found it, so this I also bought on the Prusa shop, and now they're not even available as a spare parts. I'm not telling that these are bad, but I'm sure that these were much better at that time. At least they still use the gauge belts. X-axis assembled, and now I'm moving to the Z-axis assembling. An important step in this part is installing the lead screws which are attached to stepper motors. An interesting thing to notice here that this lead screw is already joined with this stepper motor, and I saw many times a lot of companies make this error that they ruin this Z-axis by giving some cheap coupling between the shaft and the lead screw. And one more thing, that this T-nut is POM, not from brass. The brass is fine, but it is very sensitive to lubricating. If it is not lubricated correctly, then we have some additional friction. This is less sensitive to this. Here you can see the moment when I installed the X-axis to the frame of the printer. Chapter 4 is finished, and not only assembling the Z-axis but also this main cable. And this solution was much better compared to the Mark III. So connecting here these cables to this main board holder was much better here. Somewhere at the end of this chapter, I'm here installing this extruder to the holder, checking tension of the belt using this app and frequency. And the extruder is assembled, and this was the longest chapter so far. And now the LCD assembling. This chapter is also finished, but it was not only about connecting the LCD screen, but also connecting the wires, and almost all wires are connected now. And the next chapter is connecting the Y-axis. Here I'm somewhere in the middle of this chapter, and I'm installing the hotbed carriage to the printer. And this is end of this chapter, covering the main board box. And I'm almost finished installing the spool holder. Finally it's assembled, and interesting, for this I needed more time than with the Mark III. Now I'm much more experienced, but even then I know what parts do or how the printer works, but I still needed to read every line of that user manual, because if I forget to insert some nut or forget to put the cable through some channel or hole, in that case maybe later I have to go a lot of steps back to fix that error. I think my assembling speed was actually the same, but this time I needed 14 hours, and for Mark III I needed 10 hours. Now I will do some check, maybe I have to upgrade the firmware, and then I will do the calibration and see how it prints. I'm preparing the calibrations. Few small things I noticed, even the Prusas and these sample filaments without the spool, and what I'm really missing from the package are metallic tweezers. They're very useful to clean the nozzle. Latest firmware I copied to this USB drive. And actually this will be the first time I'm turning on the printer. There is a new firmware, it found it. I had to choose the flash. The flashing is finished in approximately 3 minutes. Language English. And now it will start the cell test. Well, this calibration will check several things: the fans, the nozzle, and also the X-axis. And here I had some problems because it couldn't reach completely the right side of this X-axis. But I will let it finish and then analyzing it. Unfortunately, I couldn't finish the calibrating because of that X-axis. Now I have to fix that first. The problem is this cable cover here, and because of it, it cannot move completely to the right side. As you can see, it hit this screw. It's pity that it is not on this side. In comments I saw that there is new version on the printables, but my faster solution was cutting a small gap so it will not hit the screw. Now, as you can see, the self-test completely passed each step. Cleaning the bed with some isopropyl alcohol. Load the filament, and I'm just following the instructions on the screen. And there it is on the other side. Print, and there is a keychain holder, quite short printing, 80 minutes. We have a preview image, great. Actually it is cooling down the nozzle because it will touch the bed, and you don't want to touch with 200 degrees Celsius or above. The auto leveling is only in 3x3 points like with the previous version. only this time it looks like it tests only on that area where the object will be printed. And now it's hitting the nozzle. It's a purge line, and in one thing this is really good, and that's view to the nozzle. It looks like it will be a great first layer without any settings of the Z offset or similar. We have a nice preview image here, and this is the progress bar, and let's see what settings we can do during the printing. Of course we can pause or stop the printing in the tune. Print speed, nozzle temperature, heat bed temperature, fan speed, flow factor, so a lot of setting possibilities like with the previous version too. I can change that time zone offset, okay. Back to printing. And the first layer is finished and it looks great. Of course later I will test with some bigger surface, and this is now the second layer. For the filling it is quieter than Mark III. Of course that's 5 years old printer, maybe those linear bearings are now older, but definitely for the filling it is quieter. And I will measure the noise from exactly half meter distance. All fans are working now, I will stay quiet. Approximately 45-46 decibels is the noise from it. Printing is finished. The quality. This is very easy printing, basically not much to see on it, except the first layer. This is the top surface and I'm curious for this first layer, and the quality is very equal. I'm already very familiar with these sheets, so the smooth PI sheet is great for the PLA, the textured is great for the PETG, and satin I'm using for everything else, sometimes with the glue stick, sometimes without it, but it is great even for those technical filaments. Next printing will be the Benchy. This is the Prusa slicer, and now I prepared the profile Mark IV. And with the 0.2 mm speed profile, the printing time will be 1 hour and 2 minutes. That sounds a little bit slow, but I hope the quality will be good. So let's see it. According to slicer, it requires 4 meters of filament, and I calculated here I have 5, so I hope it will be enough. We do this auto leveling with nozzle touch, and there is always some kind of micro oozing from it. Not sure how good is this solution, but it works, only we have these strings on the bed. I will speed it up this part, but it looks like it will be again perfect first layer, well at least on this small surface. And I really like this view to the nozzle. Great first layer, and now it starts with the second one. This is the third layer, and quite faster than the previous two. It is so nice to watch the printing, but it looks so slow, but the quality is fantastic, no question about that. Printing is finished, and I know the bed adhesion is still good. Well, maybe this is 1 hour Benchy, but the quality is fantastic. Absolutely no issues on any element of this Benchy. Well, except it doesn't float, but that will be solved in my next printing. Nice time to prepare the network with the USB drive plugged in. Settings, network, Wi-Fi, set up Wi-Fi network. And I am just following the instructions on the screen. And then it will save a text file to this drive, a configuration file, and here I have to enter my password and the network on the computer, plug the USB drive back, success. And after a few seconds I can see the IP address, and also inside the Prusa link I have to find the password, and these two data I have to insert into Prusa slicer in printer settings, and also I have to enter the name for the printer, OK. And it's ready. Now I can slice this object, it will be printed in the vase mode, and I will send this printing or G-code over the network. And again I'm still amazed with this perfect first layer. I can hardly wait to test the whole bed surface soon. As you can see, moving of the nozzle is smooth, there is no breaks in the movement, and this printer don't have a problems with printing in the spiral or vase mode. Basically the Mark III doesn't have this problem neither, unlike some earlier Marlin printers. And there is one interesting fact about this boat, that it floats. What I really like with this leveling method that it always touches the top of the surface. So for example, I can change the print sheets and my next printing will be on this one here, and I don't have to do any changes in the settings. And this is again a perfect first layer, independent from the print sheet and the surface, but we will see the other side later when it's finished. What I'm really missing from here are the current Z coordinates, because this was included in the Mark III even on that small textile screen, but here it's not. Because recently I wanted to change the color so the letters will be in different filament color, but I'm not really sure at what position is this along the Z coordinate. This is the top side, which looks great. These are the letters of my university logo. And on the other side, interesting, I was hoping to see more this texture from this print surface, but basically it's very flat. Now let me show you one more advantage of this printer compared to those reverse Bovden style printers like all those coreXY printers. I have to print something from this green color, but this is very old filament and very brittle. As you can see, I can break it very easily, and there is no chance I can use it in those reverse style Bovden style printers like on that Creality K1 or Bamboo Lab AMS or similar printers. And I need to print some parts in green color for this Stoli toy. And here it will be possible because the path of the filament is straight from filament holder down to extruder. And as you can see, the filament is extruding on the other side. I will print 8 objects at a time, and I will use the 0.3 mm layer height draft mode. Send directly to printer. And this is approximately 100 times speed up video. That was a time lapse of the first layers, and as you can see, each element is printed correctly. This is now the second layer. And this time I didn't use the filament guide to have more straight path of the filament to the extruder. Now here is an interesting fact. So this was printed now on Mark IV in 3 hours in draft mode. This was printed on K1 in 1 hour, and this on Bamboo Lab P1P also in 1 hour. And in all 3 cases I used the standard default settings. And now I want to test that M600 command for the filament change. It is pre-installed into Prusa Slicer, and here I want to change the color into white one. Slicing, and I'm sending the G-code over the network. Print, and after a few minutes it automatically stops. Unload the old filament, ask for a new one. I'm just following the instructions on the screen, and this is purging the previous filament so it cleans from the previous color, and then it continues in white one, and it looks fine. And it's finished, so this M600 command for the color change works. And the final result. And with this printing I want to test the bed leveling, because I'm using here almost the whole surface of the bed. I'm sending the G-code over the network, but it is quite slow. Over the cable it will be faster. Now it starts with the auto leveling almost over the whole bed. And here you can see a timeless video speeded up approximately 100 times, and each element starts perfectly, so we have great first layers. And this first layer quality it can reach without any additional settings from the human side. 10 more minutes and the printing will be finished soon. These are some decoration for my wife's office, and already did this from the wood laser cutting. Printed from Brittle PLA in marble color. And now conclusions. Well, first to answer the question, kit or assembled. Well, even for the first printer, it is not a problem to buy a kit. I mean, those instructions are extremely detailed. 5 years ago, while I had zero experience with 3D printing, I could assemble it without any problems. Actually, my assembling speed was very similar like now. And at that time, it was very useful because I learned how the printer works. I learned a few tricks about 3D printing, for example, how and where to use the hexagonal or square nuts. And I wasn't afraid to disassemble the extruder when I did some upgrades to Mark III's, for example. Now, after 5 years, when I know how printer works, I didn't learn almost anything new with assembling this kit. So the only reason I bought the kit instead of assembled is the price difference. The price difference is more than $300. This means if you know how printer works and you earn more than $20 per hour, then don't waste the time with the kit, buy assembled, and use that time to earn some money or something like that. Otherwise, I suggest you to buy the kit. Now let's talk about the printer itself. Well, the fact is that it is still one of the best, if not the best, bed slingers I tested on this channel. Not the fastest, but I think it is still the best because of those small details I mentioned in this video. Also, I have a nice comparison, Mark III versus SV06 and NS3 S1 Pro. So all those small details I mentioned there and in this video make me to think that this is still the best bed slinger tested on this channel. Now, it has very big problem, and that's the price. So it is so hard to explain why to buy this printer instead of those fast coreXY printers which are fully enclosed and we can immediately print, I don't know, ABS, and we have several in this price range. So if the Mark IV wants to survive, I think the price must be significantly lower. And we know that it can be lower because we have several clones for fraction of the price. This printer has some advantages compared to those coreXY printers. I mentioned several in this video. It is quieter, nice filament pad and similar, but the price, as I mentioned, must be lower definitely. Now what will happen to it? Well, it will go inside the IKEA lock enclosure to replace my Mark III. And for this it needs some small modifications. Now two things I don't like on this printer, and it was presented on Mark III. And one of them is the current Z coordinate during the printing on the screen. It's not included on this one. And the second is the maximum laser temperature is only 290 degrees instead of 300 like with Mark III. And I have several filaments, even Prusa filaments. One of my favorite when I need resistance to bending is the Prusa PC blend carbon fiber version. And I like to print it on 290, 295 degrees Celsius. But here the 290 is the maximum, so I'm not even sure that if I can constantly print at 290 or I have to lower here this temperature. So this is what I am missing here on this printer. If you have some other experience or help me out, what is the advantage of this printer compared to some coreXY printers I mentioned earlier? Thank you for watching and happy printing!